Live. Hi, Janshi, Konda, Chinmay, Ria, Mahesh, Alia. Hello, Nithya. Hello, Terrific IS. Hello, Chinmay. Hello, everyone. Can you guys hear me? Can you guys see me? Can you guys hear whatever I'm saying loud and clear? Do let me know in the chat box by putting up a thumbs up, by putting up a yo, or putting up a fire symbol out there. By the way, I'm the physics master teacher. I usually teach on the Enthuse channel, but on the special request of Vani ma'am, and because of your love and support, I am here. And number 3, the most important reason, because I love you guys. That's why I'm here. Okay, because I want you to be the future doctors, and I don't really want you guys to miss out on the seat of MBBS or whatever medical stream you're looking at. I really hope these sessions will truly boost your physics percentiles, your scores, or marks in the upcoming NEET examination. 1 mark counts, trust me on this. Even if your marks are boosted by 5 marks by just one session, you should attend it, because it can change your career, your future, and you should never let even 1 mark go. Thank you guys for all that love and that fire and that hearts. Welcome, your Capto. I'm your Capto, Shreyas. Oh, Yalini is also here. Some of my VNQ students are also here. Nice to see all of you. And before we begin the session, do not forget to smash the like button. Yeah, please do that. I'm pretty sure most of you have already done that. And if you are new to Biotonic, please hit the subscribe button so that you get your daily dose of updates. Now, before we go ahead, let me also quickly tell you, oh, by the way, if you want to stalk me, you can stalk me here. That's my Instagram handle, Shreyas_Vedantu. Now, this is my weekly schedule on Enthuse channel, but you can attend any of the classes if you feel like, if you are 11th or 12th, or if you have a student or a friend who is studying for JEE, or even if you're preparing for NEET, trust me, you can attend any of these classes, okay? Right now, I have planned this ray optics session with you. Again, next week, I'll plan something, and so on and so forth. I'll increase the frequency once the JEE mains is over, all right? Because right now, I'm very much tied up with my commitments towards JEE mains, but soon I'll be coming up more often for conducting more and more beast mode sessions. So let's quickly get into the session. And what is going to be the flow of the session? We are going to cover ray optics, theory, problems, quick revision of theory, quick problems. Some are PYQs, some are my own problems or from some book which I feel are very important for cracking the NEET examination. So the whole idea of today's session is to make sure that you get the confidence in the chapter of ray optics. And trust me, when I come here again for a complete syllabus mock test, I'll be conducting even more problems from all the chapters. So for now, let's focus on making sure that you are able to understand the concept and apply that concept or formula for solving problems. Okay, so let's start with reflection. Then we'll go to refraction, and then we'll go to lenses and prisms and eye defects. So are you guys ready? Good evening, Divya. Good evening, Vandana. Good evening, everyone. Shrestha. Hello, Dr. Nu. Hello, Prachi. All right. Jai Ho. And I hope you guys are doing extremely well. Let's rock the session, guys. Oh, by the way, I forgot to tell you one more thing. I really hope you guys had your dinner. I just had my dinner. And the reason why I'm telling you this is because, this session is going to be a little long. Okay, 11 o'clock. मान के चलो. अच्छा, मैं ये भी भूल जाता हूँ कि ये English channel purely नहीं है. So I'm allowed to talk a little bit of Hindi. So maybe I might use 1 or 2 sentences, but most likely ये lecture जो है English में रहेगा. Okay, so let's get going and let's get started. So at least 11 o'clock तक मैं जिंदा रहने वाला हूँ. जब तक है जान अपन चलेंगे. Beast mode on हो चुका है. Come on guys, join in, get your friends, get all the NEET aspirants in the session right now. The ray optics beast mode on session has just started. Okay, so reflection, we know that any surface which reflects always will follow the 2 laws of reflection. One is, the incident, reflected, and the perpendicular, which you call it as the normal. All of them are in the same plane. It will never happen normal is here, incident is like this, and reflected came out of the board plane. Nah, that doesn't make sense. Okay, and this law is not just valid for plane mirrors, guys. It's even valid for curved mirrors. This was actually one of the questions asked some time back. And even if you have a curved mirror, it is made up of small small flat mirrors, and every time the ray is incident, it will be reflected back. Every time there will be a different normal for the reflection to occur. So a curved mirror is nothing but many plane mirrors together. Number two, the angle of incidence and the angle of reflection are the same. That's something which everybody knows. Now, so that you guys get all these pointers, I have done one beautiful thing. I'll be sharing the PDF of this entire session. It will be like theory points, basic important formulas for quick revision. So all that you see over here will be available for download as a PDF on your Telegram and probably your description box link as well. Okay, after some time, probably you should wait till tomorrow. Now, like I said, this is valid for both plane as well as curved mirrors. Now, the angle of deviation, this is very important formula. Keep this in mind. Keep this in mind. Yeah. Angle of deviation. What is the meaning of deviation? I was going here because of something, I turned. I was going here because of some event, I turned. So the angle by which I deflect is called a deviation. In the case of mirror के केस में क्या हो रहा था? The ray was going like this. Ray ऐसे जा रहा था. Now it has turned this much. So this is angle of deviation. Ray इधर जा रहा था, अब इधर जा रहा है. Deviate हुआ इतने से. This you can see is 180 minus 2i. This 2i has come because, you know, I is equal to r. Actually it is minus I minus r. But I and r both are equal. इसके वजह से 180 minus 2i आ चुका है. And you should remember this formula. Okay? Shall we go ahead? Everybody fine till this point? Quick revision of all the concepts, guys. Come on, guys, join in. Yes, Kalpana, correct. It deviates from its path. Very good. Now, going ahead. USD join in, bacha. Ab bhi bas chalu hua. We just started, okay? Very good. Now, this simulation very easily shows you how the images are formed by, you know, plane mirrors. Jitna dur object, utna dur image. However far the object is from the mirror, that much far the image is from the mirror. Object size, image size same. Object height, image height same. But जो image होता है laterally inverted होता है. यानी कि if you are seeing yourself in the mirror, then there is another person, jadui person, there is a judwa, there is a twin created. He has exactly same nature like you. He has same nature like you, but if you are right-handed, he will be left-handed. If you slap yourself on the left cheek, he will slap himself on the right cheek. If you chew on the right side, he will chew on the left side. So that's how it works. So that is called as lateral inversion. It's your twin brother or sister on the other side. You can say hello to him. If you do a high five using right hand, he will do a high five using left hand. That's how it works. Okay. Also one more thing. जितना speed object का होता है, जितना speed object का होता है, उतना ही speed image का होता है. That means however fast the object moves, image will also move with the same speed with respect to the mirror along the perpendicular. What does it mean? Observe this. If the object moves with 2 meters per second here, the image will also move with 2 meters per second this way. If object moves this way, image will move that way with the same speed. But मान लो, imagine if the object moves here with a speed of 3 meters per second this way. Don't be foolish to think कि यार image उधर जाएगा. ऐसे कैसे जाएगा? तुम सोचो यहाँ पर मिरर है, तुम इधर जा रहे हो, मिरर इधर है, तुम इधर जा रहे हो, you are going like this. How can the image go that way? तुम भूत हो क्या? Obviously नहीं. You are not ghost, right? How can the image go that way? That will be very weird. You are walking parallel to the mirror, your image walks like that. You will freak out. You won't want that. So image will go like this. So image will also go with 3 meters per second. The only speed which flips is the velocity which is perpendicular to the mirror surface. Keep this in mind. Okay? ये समझ में आना चाहिए. Great. So, having said this, quick properties of the image formed by the mirror. The image is same size, image distance is object distance. Image is erect. मतलब तुम खड़े हो ऐसे, तो image भी वैसा ही रहेगा. It will not be upside down, obviously. It is virtual because it is formed behind the mirror and the image is laterally inverted. Okay, great. So, A lot of people ask me, sir, can there be a definition for virtual and real image? Yes, the definition for virtual, ray diagram wise, ये ध्यान में रखना, is when, you know, let's say there is a mirror or lens, कुछ भी हो सकता है, the rays appear to originate when extended backwards. So if you extend it backwards, okay, when you extend it backwards, they originate from a point, then that image is called as a real image, virtual image. That image is called as a virtual image. So when you see the rays deviating when extended backwards, actually नहीं originate हो रहा है यहाँ से, actually यहाँ से start नहीं हो रहा है, but ऐसा लग रहा है it is starting from here, that is virtual. And whenever we talk about real image, please understand the rays actually meet at a point, they meet at a point and they form that, you know, real image. And a real image, you can get it on the screen. On the screen, you need a screen to make sure that you can see that real image. Okay, so this is something which you should know. The rays actually meet, but यहाँ पर they appear to originate when extended backwards. That's the catch. Let's go quickly to spherical mirrors. Let's get quickly to spherical mirrors. Come on, guys. Yeah, so when extended backwards, it meets at a point, that is virtual image. Okay, let's go to spherical mirrors. Now, concave and convex mirrors. First of all, there will be something called as the radius of curvature. The radius of curvature. The radius of curvature, let's say for a concave or a convex mirror, if it is R, the focal length is always the midpoint of center and the pole. So that is the reason why you will always see R is twice the focal length. R is twice the focal length. Let me see if I can answer this quickly. If I take the spherical mirror and I got angry and I put it inside water, that means there is a refractive medium mu surrounding it. Then what will happen to the focal length? Quickly answer in the chat box. Quickly answer in the chat box. What will happen if I immerse a mirror inside some medium, let's say water or glass or anything? What will happen? No change, correct? Exactly, no change. It will not increase. The change only happens for lenses. Lens में बदलाव आता है, lenses में the focal length changes, but in mirror it never changes because it is only dependent on the radius of curvature, nothing else. ये चीज समझ में आना चाहिए. It is only dependent on R, nothing else. Keep this in mind. Okay, great. Now you can see if a ray passes parallel to the principal axis, वो focus से जाएगा, it will go through focus. Similarly, if a ray goes through center of curvature, it will again come back through center of curvature. Keep this in mind. If a ray goes through center of curvature, it will reflect and it will again come back. Now the mirror is not shown over here, but let's say the mirror was like this. It will again come back because this will be perpendicular. Okay, so keep this in mind. All right. Now going ahead to see the formulas. Mirror formula, everybody, come on. 1 by F is 1 by V plus 1 by U. Always use sign convention. Always use sign convention. Keep this in mind. Okay. Magnification. This magnification, image size. You can see this is image, object. Image height, object height is minus V by U. Minus V by U. And when I say, for example, let's say this magnification comes out to be minus 3. What does this minus 3 stand for? This minus tells it is inverted because it is flipped. 3 says that it is extended 3 times, so it is inverted and magnified. It is inverted and magnified. Similarly, let's say this was plus 0.2. Plus 0.2. What does plus tell you? It is erect. It did not invert itself. So to check whether it is erect or inverted, always check for the magnification. And if it is 0.2, मतलब अगर object height 1 meter था, image has become 0.2 meters, so it is erect and diminished. That's how you should look for it. Yes, perfecto. Another thing, हमेशा sign convention जब लगाते हो, people get confused. They think left side is minus, right side is plus. Origin is the pole. That is completely wrong. अगर आपको किसी ने ऐसा पढ़ाया है कि left side is minus, right side is plus, center pole is origin. That is wrong. ऐसा नहीं होता. In fact, कैसे होता है guys? हमेशा wherever incident rays go, these are incident rays, that direction is positive. The direction in which the incident rays goes, that is positive. The pole is the origin. The pole is nothing but the origin, undoubtedly. So if that direction is positive, ab socho, if this is origin, that direction is positive, hence whatever is here will be positive and whatever is here will be negative. Understood? So that side is positive because incident rays are going that way, and this side automatically will turn out to be negative. Now if somebody asks you, what is the focal length? What is the focal length? Maybe let's say this is 10 meters, example. Let's say this is 10 meters. The answer won't be 10. This point is on the negative side, so minus 10. This will be minus 10. Okay? Similarly, look at the center of curvature. Center of curvature is here. So the radius of curvature, look at that. This radius of curvature will be also negative. So R will be minus 20 meter or whatever, centimeter, anything, whatever it is. Understood? Clear? Okay? Similarly, if you look at the object distance U, is this positive or negative? Check this. The coordinate is negative, so it is negative. Check the image. Image is also on the negative side, so image is also negative in this case. If the image was positive, then the image would have been virtual. इस case में ये real image बन चुका है. Okay, it has formed a real image. Clear? Very good. Very good. So these are quickly revising you all the concepts, very, very important things. छोटे छोटे चीजें होते हैं जब कोई बताता है, when somebody tells you, then you get a hang of it. Now this is also very interesting. Very interesting. Very good BTR, very good Divya, very good Vandana. Yes, so says Maria. And Shubarna, excellent Esanvi, KS Banashri, very good Pujita. Thank you very much for all the love, guys. All right, let's get going. Let's get going. And now, longitudinal magnification. What is this longitudinal magnification, guys? So, see, when we talk about normal, this linear magnification, we are talking about its stretching or diminishing along the perpendicular direction. Along the perpendicular direction to the principal axis. But if you observe this carefully, you will see this particular candle also might change in width in this image. Do you see that? This is the width of the object, this is the width of the image. So this is called as your longitudinal magnification. Width of image upon width of object. So that's when you are along, stretching or diminishing along the principal axis. Keep this in mind. So this is the stretching effect along the principal axis, and surprisingly derivation करके आ जाता है. It comes via derivation. It comes out to be minus v square by u square. Okay, so minus v square by u square. बहुत simple है guys. If this is minus v by u, इसका square कर दो. Minus v square by u square बहुत simple है. And it is also image velocity. So this image might be moving with some velocity, image velocity upon the object's velocity. Image by object, width of image by width of object, which is minus v square by u square. Okay, straightforward formula. Straightforward formula. Cool. Yes, square karo, baat khatam. Very true. All right. Cool. Next thing coming up, power. Many people do not remember the formula for power for mirrors. Mind it, it is minus 1 by f. People remember it as plus 1 by f. There is a small catch. See, plus 1 by f जो है ना बच्चों, it is for lens. ये mirror है, so it is negative. In fact, whatever formulas I wrote over here are all valid in lenses with a small change. जहाँ जहाँ plus, wherever you see plus, replace with minus, and wherever you see minus, replace it with plus. So if you put minus, it becomes lens formula. If this minus becomes plus, it becomes linear magnification for lens. If same thing, this kind of longitudinal magnification, just replace the minus with plus, and power also, instead of minus 1 by f, you write it plus 1 by f. It all becomes true for the lens. That's an easy way. तुम्हें एक चीज याद है, you remember the next thing. You remember one, आपको दूसरा चीज याद हो जाएगा. Okay? Cool. Great. Let's start solving some beautiful questions coming up on your screen. Get ready, guys. Yeah, here's the first question coming up on your screen now. Okay, let's see whether you can do this. I'll probably put up a timer for this. Maybe I'll just pause it for now. Though plane mirrors are inclined at an angle of 60 degrees with each other, a ray of light which travels horizontally is reflected first from the mirror and then from the other. The resultant deviation is. Okay, so guys, what it means is, you have your two mirrors, something like this. Okay, there are two mirrors, something like this, and this is nothing but 60 degrees, and your ray is coming like that. The question is, by how much will it deviate eventually? Starting the timer now. Come on, interesting. Some of you are saying A, some of you are saying okay, everybody is saying 60. अच्छा क्या बात है, सब लोग का मन 60 पे अटक गया. Somebody is saying, Shruti is saying D also. Okay, interesting. 99% people saying A, very few people saying D. Very, very interesting. This is मजा आ रहा है मेरे को तो. A आ गया सर आंसर. अच्छा क्या बात है, easy. What if I tell you, you guys are wrong? That's why you are attending my session, or rather that's why you should attend my session. Somebody is saying B now. Shreyas Kumar is saying D. Acha. Somebody, Vedant also saying B. Okay, interesting. So let me tell you, most of you guys were wrong and the time is about to be over. I just love the sound of the bell which is made the moment the time is up. So I'll just wait for it for 2 more seconds. Ta-da! Okay, now let me show you how to do this. First, draw a normal. Okay. Now, think guys, if this is 60, even this is 60. Obviously, two parallel lines make the same angles. Everybody knows this. When you have parallel lines, these angles are same. You have learned this in 9th or 10th grade probably. You will observe, okay, let me draw a big diagram so that you will love it. Okay, this is a big diagram. Okay, now the ray comes like this. Okay, by the way, this angle was 60, I suppose. Okay, I will draw a normal out here like this. Now, I quickly got this 60, therefore this is 60. Now, this is normal, correct? This is normal. So, obviously, this would be 30 degrees. We know angle of incidence and angle of reflection should be same. So, hence, it will reflect also at 30 degrees. So, this is also 30 degrees. Great. Next, I will draw another normal over here. Now, I need to figure out how much is this. So, for that, here is what I'm going to do. Let me draw a vertical line. Now, see guys, this angle is 90. If this is 30, this is 30, how much is this? Obviously, this is also 30, right? This will be also 30. Cool. 30, 30, 30 will give you 90 degrees. Now, if this is 30, how much will this be? This will be also 30 degrees. Cool. This is the angle of incidence. Light is falling on it like this. The light came like that, fell on it like this. What will happen? It will also rebound like that. Exactly the same angle over here. So this will be also 30 degrees. Beautiful. Great. So how much will this angle be? This will be 60 degrees. Hence, if this is 60, how much is this? This is also 60 degrees. Now I know what you guys are thinking. I know what you guys are thinking. Sir, light was incident like this. It finally got reflected like this. Sir, it has turned by 60 degrees. Wrong, my dear friends. Wrong. Now think very carefully. The light ray which was going like this has turned like this. How did it turn? Like this. It went here, turned like that. So the total angle is this much. This is delta. This much is delta. So can you guess how much this angle is? 180 plus 60. So 180 plus 60, which is 240 degrees. And that's why the correct answer is D. Done, done. Understood? क्लियर हो, अमेजिंग हो, मजा आएंगो, very good. Menti quiz will take later on. First, let's understand the concept. Yeah. Very good. Very good. Don't worry, Nivya. I'm here for all the English medium students. Chalo, let's get going. And by the way, you have gained confidence and probably marks now. If this kind of question comes in the examination, you can thank me later. If I ever come someday when you become a doctor and I'll be like, okay, मेरे पैरों में दर्द है, मैं नहीं चल पा रहा हूँ, I'll become good and be like, please help me. Probably after 10-20 years. No, not 10-20 years, more. Huh? Okay. Okay, chalo, next question coming up on your screen now. A person is in a room, FMC 2002 question, whose ceiling and two adjacent walls are mirrors. How many images are formed? बहुत ही बढ़िया question. Let's see. मैंने अपना वर्ड वापस ले लिया, जूते मत मारो. यार अभी तो मैं जूता नहीं पहन रहा हूँ, तो I cannot hit जूता. If I was wearing shoes like it used to happen in offline coaching, then I would have thrown jutas. But अभी जूता नहीं है. अभी पेन फेंकना चाह रहा हूँ, but एक ही पेन है. So I'll not throw the pen. You are safe. Chill. Okay, let's do this. How many images are formed? Imagine yourself in your wherever that room where you are standing, sitting, studying, whatever. This wall, and the wall on the top, all are mirrors. So think about it. How many images are formed? Beautiful question. Some of you are saying 8. Some of you are saying what is that? A, which is 5. So many of you are saying 6. Interesting. This is getting interesting. Now I'll tell you what you should do. Okay, observe. मैं क्या कर रहा हूँ? ध्यान से सुनो. Okay, बच्चा लोग ध्यान से सुनो. Okay. Okay. Just observe this. Okay. Now, I hope you can visualize this where probably यहाँ पर आप खड़े हो. This is you. Okay, this is you. Okay, this wall, and the top wall, all are mirrors. What are they? They are all mirrors. एक एक करके निपटाओ. Just imagine, because of this mirror, which mirror am I talking about? This part. Okay, whatever is there on this side will be reflected back behind. Whatever is there here will be reflected back behind. So if you look at it from the top, think of it from the top view, guys. You are seeing this and you are seeing this Pandu, this guy which is there, his head you are seeing. So if you consider this mirror, the one over here, then whatever is there over here will be reflected behind. Whatever is there here will be reflected behind. So you will see, if this is your object, you will see the image over here. You will see the image over here. Whatever is there in the front, you will see behind. Also, this mirror will get extended. If there was a mirror in front of mirror, that mirror will also come over here behind this, in the reflection in the image. Now, this is like a big mirror. This is like a big mirror. This object will form an image here. Think about it. This object will form an image here. Okay, and this image will also form another image over here. This will be I3. Everybody getting it? Think about it again. Pandu is the name of this person. Okay, nobody has met him, but he is only seen on the screen. Okay, now think what has happened. Because of this red mirror, whatever was there in the front has gone behind. So even this mirror has come behind over here. Now that entire mirror at the back will reflect whatever is there in the front. So 2 more images. Last thing, there is another mirror on the top. So whatever things you saw here, like I1, then I3, and then I2, will also be replicated on the top. Whatever you saw here, you will see another 4 images on the top. 4 more images on the top. So guys, now count the number of images. 1, 2, 3 plus 4. How much is it? It is 7. Understood this? Don't count the object. Don't count the object. Yep. Clear? So this is how the answer is C. A lot of people just count the object also and mark the answer as D. Do not count the object. Object is not image. Excluding that. Yep. That's how you need. No formula needed, Tanya. No formula needed. It's pure visualization. If you go by formulas, you'll waste more time. A lot of people give formulas and do via some crazy, silly methods. Don't do that. Simple. Okay? Keep it simple. Yep. So Pandu will have 7 images. Socho na kya ho raha hai? Tino dimensions. In all the 3 dimensions there are mirror. X, Y and Z. So this mirror will reflect you. That mirror will reflect both of you. The mirror on the top will reflect all the 4 things below. So totally 8, but one of them is object, so neglect that. All right. So correct answer is C, I believe. Yep, it is. Next question coming up on your screen. Ek miss ho gaya. Koi baat nahi. Next question. There is a person standing in the center of a room. Beautiful question. Let's see how many of you can do this. And looks into the plane mirror fixed on the wall. What is the minimum length of the plane mirror for him to see the full length of the image of the wall behind him? Interesting. Come on. Saloon में infinite images आ सकते हैं. Dalip Singh. Sanjay saying 4. Okay. Come on. Figure this out. So, how to do this kind of questions? This is our wall. How much is the length of the wall? That is 12 meters. Okay. Now, this is the ground. Let's get our Pandu back in action. ये आपका Pandu है. These are his beautiful eyes. And there is a mirror in front. Okay. So now how much mirror is needed? I don't know. So this is the mirror. Now how much mirror is needed? That's the question. So for solving that, take a big mirror. Let's see how many rays pass. Based on that, I will neglect the other parts. I will only choose that part where the rays of the mirror are passing, and that is the mirror which is required by me. So think of the extreme points and see how the rays will look like. This topmost point of the wall, when it enters Pandu's eyes, it will look like this. And this bottommost point from the wall, when will it reflect back, it will come like this. So this is how it is entering his eyes. Correcto? Now visually think, guys, just reflect this behind, because this is a mirror, right? So whatever is there here, just pull it out like this. Just pull it out. It's like a paper which is being bent. It has been folded. Just open up that fold. Okay, it will become easier for you to solve. Trust me on this. This will become easier for you to solve. So I just opened up that fold. Okay, so open the fold method. Open the fold. That's what I have done. Now observe, guys. See, Pandu was standing exactly at the center of the room. If you are standing at the exactly center of that room, that means this distance was this distance. So if this is x, this will be also x. And if this is x, when I unfold it, this would be also x, right? From here till here will also be x. This is x, and even this is x. Clear? Okay. Now just think about this. Look at this small triangle. Look at this small triangle and look at the big triangle. So my point is that big triangle with base of 12 meters and that small triangle over here, which is on that mirror. Aren't you seeing both are similar triangles? Aren't you seeing both are similar triangles, guys? This big triangle and this small triangle, they are similar triangles. In what ratio are they? In what ratio? No, not 1:2. A lot of people make this mistake. It is not 1:2, bacha log. Look at the height of the triangle, the big one. X, x, x. It is 3x. Be careful. This is 3x. So over here, what is this height? And what is this height? This is just x, right? So what is the ratio? 3:1. Did you see? This is 3, this is 1. This is big triangle is 3 times more. Correct. Hence, or 1:3, whatever you have to say. So if this is 12, how much will this be? Think about it. How much will this be? It will be 12 divided by 3, which is 4 meters, which is option A. This is 3 times smaller. So this one is 3 times smaller, hence the answer is 4. Understood? Yes, that's how you do it. Very good. Excelente, Isha. Excelente, Manmad. Very good, Shiny. Excelente. Very good. Correcto, Alia. Let's get going to the next question. Beautiful, creative, imaginative questions. Okay, next question. Thank you, Pandu is a cute name. Glad you are able to imagine this, 3-star. All right. So, if an observer, RPMT 1999 question, is walking away from the plane mirror with 6 meters per second, this should be solved very easily, guys. Then the velocity of the image with respect to the object is, come on, not more than 1 minute. It's very easy. Come on. Very, very simple. Come on, my Biotonians, come on, my warriors, you should be able to do it. Hi, Chitra. Pandu is very famous, I know, more famous than me, I guess. All right. Everybody is saying C. Some of you are saying B. Okay, interesting. Happy boy, I'll take semiconductor someday, bacha. Okay, very good. Probably I should end this. Proud of you. Yes, the correct answer is 12 meters per second. Proud of you guys. Very good. See, if the mirror is here, if the object is here, if the object moves with how much speed? 6 meters per second. Cool. Then the image will also move with 6 meters per second. Object goes there, image goes there. Relative. The question is relative. So relative will be 6 plus 6, which is 12. That's the answer. Both are going opposite. Their speeds will add. Hence 12 meters per second. Very good. Okay. Chalo. Let's see whether you can get the next question coming up on your screen. I'll give you 1 minute to actually even read the question as well. Okay. Here comes 1 minute timer for all of you. Very good, sweet weapon. Correcto, Sanvi. So there are multiple rays shown and there is a concave mirror also shown. PQ is the ray which is incident. How would the ray which will reflect actually travel? Will it be 1? Will it be 2? Will it be 3? Or will it be 4? Very interesting. You should get this. Chitra was searching where was Capto. Capto is on Biotonic today, not on Entheus. Okay, come on my warriors, figure this out. Very, very simple. Okay, very good, very good, very good. Many of you are saying C. Okay, let's see whether you guys are correct or whether you guys are wrong. Excelente, excelente. I want to hear the bell sound. It's very cool, guys. Okay, just wait for 5 seconds more. Okay, correct. Let's see. Yeah, it is C. Because reversibility principle of light. If a ray is parallel, it will pass through the focus. If a ray passes through the focus, it will become parallel. So this is reversibility principle of light. So if incident is made reflected, then the reflected will become incident. So that's how things work for any kind of optical devices. Very interesting question. There is a point object which is placed, which was asked in MPCET 2003, at a distance of 30 centimeters from a convex mirror. Focal length is given. The image will format. Come on, figure this out. I'm not drawing the diagram. Let's see how many of you can get this. Come on, come on, come on, come on, my warriors. Gen C I will do for all the high weightage chapters, but for all the chapters, if you want it, please check out the crash course. There is a link in the description box. All chapters revised before your NEET examination with assignments, with tests, part tests and full syllabus tests. Everything is there. Please check out the crash course, bacha. It's there. Okay, for all the subjects, physics, chemistry, maths. Take it up. Okay. Infinity. Oh my God. Is it? Is it? That's why I am here. You know why Capto Shreyas is here? So that you guys, Biotonians, become doctors. Biotonians get good colleges. Else, you will probably miss out on few colleges or few marks. The answer is not infinity. Read the question carefully. It's a convex mirror. Read the question carefully. It's a convex mirror. You guys made a mistake. Hai na? That's why you guys need me and I'm there for you. Don't worry. Shreyas, Capto Shreyas, always there for everyone. And what is the object distance? Object distance. Well, that's 30 centimeters. Convex mirror, focal length is plus 30. Do not forget that. Cool? So 1 by V minus, plus 1 by U is minus 30. Be careful. Object distance minus 30 is equal to 1 by F is 30. Flip it there, all right, just shift it there. So we'll get it 1 by 30 plus 1 by 30, which is 2 by 30, which is 1 by 15, but that's 1 by V. So V is 15. Where is 15? Yeah, we got it. Behind. Why behind? Behind means it will be here. This is positive. That means the image will be formed here, behind the mirror, not front. Yeah, correcto. D. Yes, excellent. Understood? Let's get going. It was not infinity, so read the question. Okay, beautiful. Let's solve. Next question coming up on your screen now. An object is placed at a distance equal to, okay, something. Let's see whether you can solve this within 1 minute timer. Equal to the focal length of the convex mirror. The focal length of the mirror be f, and the distance of the image from the pole of the mirror is less than, equal to, more than, or infinite. Come on. Very good, Andal. Very good, Ritvika. Very good, Alia. Very good, Aditi. All right. Yes, Dhanashri says clear. Oh, Alini also understood. Oh, after a long time, BTR gaming. Yes. Shweta, don't cry, bacha. We are all there. You have to learn from your mistakes. Okay. Yes, Captain Jack Sparrow, Shreyas Sir on NEET channel. Ajuba ho gaya. Kaise ho gaya? Lot of you are saying A. Some of you are saying C. Interesting. Come on, figure this out. It's not that difficult. I would be happy if you can solve this much before the timer. Less than F. Okay. I'm going to close this. Let's see whether you guys were actually correct or wrong. Some of you also said B. By the way, the answer is less than F. Again, it's a convex. It's a convex mirror, guys. Be careful. So, you know, you just have to, where is this? Yeah. The 1 by V plus 1 by U is equal to 1 by F. So 1 by V plus U, object distance. Where is the object distance? Equal to the focal length. So U is minus F. This is minus F. Understand? U will be equal to minus F. Focal length is positive. That will be plus F. It's on that side. Remember, the focal point will be here for a convex. Do not forget, again, it's a convex mirror. So 1 by V is equal to 1 by F plus 1 by F, which is 2 by F. So V is equal to F by 2. So less than F. You can see that. It's half of F. Obviously, it's less than F. Correct. That's how it is. घंटी नहीं बजाए हम लोगों ने. आगे बढ़ते हैं. Next question. But before that, I think we have refraction. Okay, so reflection done. Let's go to refraction, guys. I hope you guys are having fun. Time for me to have some quick water break. You guys too can have your water break. Okay. Guys, if you have some specific doubts, please leave it in the comment section. After the session ends, trust me, Nandana, I'll answer to your queries. Okay, just leave it after the session is over. I'll explain it over there. Don't worry. Okay, refraction. Now, quickly, whenever light changes medium, speed of light changes, and the angle which the light ray makes with the normal also will change. If it goes into a denser medium, it bends towards the normal and the speed of light reduces. But if the light goes from dense to the rare medium, it will bend away from the normal and the speed of light will increase relatively. Mu1 and mu2 are the absolute refractive indices of the medium. I and R are the angle of incidence and the angle of refraction. Then by Snell's law, sin I by sin R is a constant, which is 1 mu2. Okay, which is 1 mu2. And 1 mu2 is mu2 by mu1. Mu2 by mu1, but it is C1 by C2, which is also lambda 1 by lambda 2. The reason why this happens, so keep this in mind, guys. 1 mu2 is always mu2 by mu1. Okay. Now, how you pronounce it and how do you infer or how do you visualize this? Whenever 1, 2 is written like this, light is going from 1 to 2. So if I say mu, monkey, donkey, okay, what does it mean? The light is going from the monkey medium to the donkey medium. Understand that. Cool, great. So next thing, 1 mu2 is always C1 by C2, which is also lambda 1 by lambda 2. Now how does this come? C is F lambda, C is F lambda, and F is same for both medium. It's same for both medium. Keep this in mind. So hence it will get cancelled off. Cool, clearo, very good, very good. Now if you ever get confused now, See, just remember only for mu, the numbering is different. Rest everything it is simple. 1 mu 2, C1 by C2, which is lambda 1 by lambda 2. Only for mu it is mu 2 by mu 1. That's all. That's all you need to keep in mind. Okay. So that is sin I by sin R. Now, the other concept, which is critical angle. Now, what is this critical angle? When light goes from dense to rare only, when light goes from dense to rare, there is a chance that if the angle of incidence is large, it will not come out. You can see for small angles, the light partially reflects and partially refracts. It will get reflected inside the medium and it will come out partially outside the medium. But beyond a certain angle, it will only get reflected. That concept is called as total internal reflection. You can see that till theta is equal to theta c, it will just come, but after theta is more than critical angle, it will only get reflected. Observe this animation. Right now theta is less. It is going reflecting in plus coming out. It's reflecting in plus coming out. This is critical angle. It's coming out at 90, and after this it will only get reflected, it will not come out. Okay, so that's how it works. And the formula for the critical angle is, remember, sine theta is 1 by mu. Okay, so don't remember it like this. I mean, it's fine. Oops, I didn't want to open this. Hold on. No. Okay, I want to go back. What the hell? Okay, thank God. I'm back. Okay, so sine theta c is 1 by mu. Keep this formula in mind. So mu is the refractive index of the dense medium with respect to the rare medium. Theta c is that critical angle. So for critical angle, when I is theta c, then the refracted ray is at 90 degrees. Keep this in mind. Okay. So if critical angle is there, then the refracted ray will come out at 90 degrees. That's something which you should know. Cool. Let's get going to the next part. Okay, apparent depth and apparent height. Apparent depth and apparent height. Okay, look at this now. If a fish observes a bird, fish, तो मच्छी हो, पंछी को देख रहे हो. You are a fish observing a bird. The fish, let's say, probably might get hunted by that bird. It's a kingfisher or I don't know. The bird always looks slightly higher than what it is. The fish, machi, you're inside dense medium. You might think, oh, the bird is very far. Actually, the bird will be close. Okay, the apparent height is more. Apparent, what is perceived by you is slightly more. So, if you want the apparent height to be more, this is how you're going to remember the formula. Apparent height will be mu times the actual height. See guys, it's simple to remember. Mu is more than 1, no? Mu for water, what is it? 1.33. For glass, it is 1.5. So, when you multiply by a number more than 1, this height will be more than this height. You don't have to remember, sir, divide karna hai ki multiply karna hai. अरे भाई देख ना, simple है. Apparent height is more, so multiply. खत्म बात. Yes. Now think about it. What will happen? What will happen? Yeah. So apparent is more than h. If the bird observes the fish, if the panchi observes the machi, bird will look. Hey, the fish is so close to the water. I don't have to dive in so much. I will probably snatch it by just dipping my feet a little bit inside. But actually the fish will be deeper. So both of them are getting fooled if you think about it closely. Machi thinks, the fish thinks the bird is far, and suddenly the bird pounces and like, oh, what the hell happened? And the bird thinks, oh, the fish is at a shallower depth. I just don't have to dive in too much. And then to its surprise, actually it's much deeper. Okay, so because this is less, how do you do this? Divide it. Divide it. Very simple. So this height is less than the actual depth. So divide by mu, because when you divide by a number more than 1, you get the depth as less value. Clear? Very good. Very good. So let's get going to the next one. Single surface curved refraction. Yes, single surface. Oh, but you will be like, sir, क्या actual में ऐसा होता है? नहीं. Both of them know by evolution कि when I see the bird, the machi knows, it has learned through generations and generations and generations, passed on information. जब मेरे को ये bird इधर दिखता है ना, actually इधर नहीं, it is actually much closer. And the bird also knows, when I see the fish here, actually the bird is much deeper. That's why it has survived and evolved. Okay, नहीं तो फिर it would not survive so many generations. Anyways, going ahead, single surface curved refraction examples. Imagine guys, you are having this jar of fish you might have seen in somebody's house, and there is this beautiful fish which is moving. Okay, this beautiful fish. I hope this is the fish. Okay, these are its fins, and this is doing bud, bud, bud. Okay, and this is you. This is Pandu. Okay, so whenever you see the fish, understand that the rays which will come out will refract at a curved surface. So you might see the fish bigger, smaller, somewhere else, depending on how the rays refract. So that's an example of single surface refraction. Yeah, correct? So that's the example of single surface refraction. What is the formula? Standard formula, mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Now, in case you are confused about what is this mu2, what is this mu1, see, where is incident? Incident is in mu1. So, incident is in the object or where the incident rays are. So, this mu1 is where the incident rays are, and mu2 is the refractive index of where the refracted rays are. Refracted rays are over here. So, that's how it is. And what is r? R is the radius of curvature. So you can see this will have some radius. So that is nothing but the radius of curvature of the curved surface. One last formula over here for magnification. So, oops, I think I have noted it down over here probably. Yes, the magnification is V mu1 by U mu2. Looks confusing. I'll tell you how to remember it. Forget this for now. Just forget this. See, the magnification, the image by object height. Look at this formula. See, usually magnification was V by U, correct? Remember mirrors or lenses, it is V by U. Now look over here. What is going with V? V is going with mu2, below. So V and mu2 is below. V and mu2. Mu2 is below V, okay? Similarly, who is going with U? Mu1. So mu1 and mu, both are, if one is in numerator, other one is in denominator. So just put opposite. That's it. You will get the answer. It's the same thing, guys. That's how you can easily remember. Usually it is V by U. What is going with V? Mu2. So V by mu2. And what is going with U? Mu1. So U by mu1. That's it. That's the formula. Okay? You can never forget this after now. Very good. Very good. Cool. So let's get going. Come on to the next question coming up on your screen. And there we go. Okay. I'm not sure why is it like this. Okay, oops, this was not supposed to be shown. Okay, so I think probably the diagram is not complete, but whatever. So there is a slab, guys. Okay, there is a slab and the bubble is seen. Okay, this is the bubble. When seen from here, the depth is something else. And when you see it from the other side, then the depth is something else. The question is, what is the actual width? Okay, what is the actual width of that particular slab? Okay, come on my warriors, figure this out. What should be the answer? This is not that difficult. Is it 3.75? Quickly start scribbling. Come on my warriors. Shubharna saying B. Interesting. Ananya saying B. Come on, figure this out. Okay, come on my warriors. Just 1 second. Yep. Okay, chalo. Let's see what the correct answer should be. Most of you are saying B, some of you said D, some of you said C also. Okay, very, very interesting. Very, very interesting. So let me tell you guys what you should do. First of all, you see the object. It appears, this is apparent, at 5 centimeters and 2 centimeters. So from one side it appears at 2 centimeters. That means the actual depth will be, mu times more, because apparent is always less. So 2 was actually h1 by mu. What is mu? It is 1.5. Think about it. This was apparent. And when you are outside in a rare medium, the bubble always, or whatever is there inside, always appears closer. So h1 will be 2 into 1.5. which is 3 centimeters. So this much is nothing but 3 centimeters. Similarly, when you see from that side, okay, the actual depth is h2. So the apparent depth was 5. So 5 is h2 by mu is 1.5. So h2 will be 5 into 15, 75, so 7.5 centimeters. Hence, the total addition, h1 plus h2. So h1 and h2 together, how much will it be? 3 plus 7.5 is 10.5 centimeters. Hence, the correct answer is C. Very good, very good, very good. Many of you made a mistake though. Many of you said B as well. Be a little bit careful. Yeah, be a little bit careful. Very good. Let's get going to the next question coming up on your screen. Yeah, the answer was C, I suppose. Yep, it is. Here comes the next question. This you should get it within 20 seconds. Within 20 seconds. Come on, come on, come on, come on, my warriors. Come on, come on. A ray of light traveling in air has wavelength lambda, frequency and velocity v and intensity I. If this ray enters into water, then which of the following parameters will change? Think about it. Which of the following parameters will change? Come on, come on, come on. Think about it. Yes, Sonakshi Thoil, you can do that. 1.5 into 5 plus 2 as well. Yes, you can do that. It will work because both the mediums from both sides are same, hence it will work. Okay, B, sure? Yes, very good. No, not C. Come on guys, speed will change. Speed changes. Only frequency, basically that color, will remain same. Speed will change, even intensity will change. You will be like, sir, how? See guys, when light is incident, a part of it gets reflected and a part of it gets refracted. So not all the intensity comes inside. So hence the intensities which are reflected or refracted are generally slightly less than what is actually incident. So keep this in mind. So only thing which remains same is, the frequency. Wavelength will also change. Okay, come on my warriors. Next question. There is a point object 24 centimeter above the surface of water in a lake. A fish is inside the water and it will observe the image to be at a point where, very, very straightforward. You should get this within 30 seconds. Come on, direct application of formulas. I am making you practice all the formulas so that you do not forget. Next time these kind of questions come, you have to get the marks in the NEET examinations. HU are saying D. Very interesting. Let's see. So Giri, I will not be coming tomorrow, bacha, but I'll be coming on VNQs. I'll come on Biotonic very soon again. D for sure. Somebody said, Aditya said C, I guess. So if you are inside of water and if you see an object which is 24 centimeters over here, obviously the image will be slightly higher. And this height will be mu into h because you are in dense and the image is formed slightly on the top. So mu is 4 by 3 into h is 24. So 3 8s are 24, 8 4s are 32 centimeters. So 32 centimeters above the surface of water, which is option D, my dear warriors. Yes, that's correct. Beautiful. Let's go to next tricky question coming up on your screen. Let's see how many of you get this. I would be very proud if you guys get the answer for this question, guys. Come on, I'll give you 1 minute to solve. Not more than that. You should be able to do this. So for the given incident ray as shown, for total internal reflection, where will internal reflection happen? Here. Why? Because this is dense, this is rare. Always internal reflection happens when light goes from dense to rare, not from rare to dense. So what should be the refractive index of this slab? It should not be prism, it should have been slab. Anyways, come on, let's see how many of you can get this. Quickly, my warriors. 1 minute timeline. Quickly solve, you will get the answer. It's not that difficult. Don't worry, Ria, you will get it. You will get it. Just try a little bit harder. Trust me on this. Come on, come on, come on. Many of you are saying C. Rajendra is saying D. Interesting. By the way, guys, I'm pretty sure many of you would have joined late. So today's session is a beast mode session where we are completing the chapter of ray optics via revision and problems. concept problems, and this is aiming for all the NEET aspirants who want to score above 150, no matter what your score is in the mock test. And trust me, this is very important that you attend complete session, and this is a big session. I started at 9 o'clock. If you have joined in late, you can watch the replay later on. For now, attend the class live, and towards the end, okay, if you still have something to say, you can leave it in the comments. Also, the lecture will be going on till a long time, let me tell you. Okay, thank you, Alia. Yes, so what you need to do, let me tell you. First of all, okay, refractive index is what we need. Okay, so this angle will be that critical angle. This will be that critical angle, correct? Because it is getting totally internally reflected. Cool? Okay. Next up, if this is theta c, even this is theta c, correct? And this is angle of refraction. And refraction will be 90 minus theta c. Why? Obviously, this is totally 90. This is complementary angle. Cool? Great. Now, for total internal reflection, I just told you sine of that critical angle is 1 by mu. Didn't I tell you that? Great. Similarly, for Snell's law, so by Snell's law, think about it, at that surface over here, sine of angle of incidence by sine of angle of refraction will be the refractive index. Okay, let's rearrange and see what happens. So sine 45, that's 1 by root 2. Sine r, I cannot do anything. Maybe I'll just take it there. So 1 by root 2 is equal to mu sine r. Now I know I want sine r, but I have, okay, I can do one thing. Guys, this r is 90 minus theta c. So how about replacing this r with 90 minus theta c? Okay, because I know sine theta c, I can do something maybe, but this becomes cos theta c. Sine 90 minus theta is cos, remember that. Okay, what can I do? Do you remember one theorem? Cos is, or rather cos square plus sine square is 1. So I hope you know this formula. I hope you have learned this formula back in 9th or 10th grade. Cos square plus sine square, since it is 1, so cos is nothing but root of 1 minus sine square. I can use this, right? Sine square, take it outside and take the root on both sides. So think this way, guys. I will have 1 by root 2 is equal to mu. What is cos theta c? Cos theta c will be root of 1 minus sine square theta c. And sine square theta c is nothing but 1 by mu square. Correct? Sine theta c is 1 by mu, so I square it. So here I have 1 by root 2 is equal to mu. Now just take the LCM. So this will become mu square minus 1, and that mu square will come outside the root because LCM has been taken. Now this mu and this mu will cancel, and I'll have 1 by root 2 over here. Square both sides. So I'll get 1 by 2 is equal to mu square minus 1. So 1 is equal to 2 mu square minus 2. Therefore, take 2 over there. So 3 is equal to 2 mu square. Therefore, mu square is equal to 3 by 2. Therefore, mu is equal to root 3 by 2. So this will be a tricky question which only the toppers will be able to do. So if you want to be a topper, if you want to get really good marks, you should do this. That's the answer. Preeti, it is not recorded, bacha, it is live. Okay, Chitra, come on, bacha, you're giving up too early. Come on. Let's do this. Interesting question. Yes, the correct answer was root 3 by 2. Yes, that's how it is. Okay, it's very interesting. You just need to go via the steps. The catch was there was a cos somewhere and there was a sine. So you should click. How do I convert sine to cos? Either by complementary or by sine square plus cos square is 1. So if it clicks at that moment, that's it. Okay, let's do this question. AIPMT 2001. A disc is placed on the surface of a pond which has a refractive index this much. A source of light is placed 4 meters below the surface of the liquid. The minimum radius of the disc needed so that the light does not come out. I'll tell you what is happening in this question. Say you have this surface 4 meters below, you have, a source of light. This is my source of light. Light rays go everywhere. Now, the light rays which are coming out at small angles will easily come out. It's going from dense to rare, so it will bend like that. But there will be one ray which will be incident at critical angle, and that ray will just come at 90 degrees. Okay, any ray after that, any ray which will come after that, think it will have more angle, so it will get totally internally reflected because that angle will be more than theta c. Correct? Now this source will emit rays everywhere throughout the pond. This is not just 1D. Just imagine there will be rays everywhere, and only the rays which are at small angles will be coming out. And if you notice, there will be a disc-like structure, a disc-like thing formed over here. Only through this circular area the rays will come out. Are you able to visualize that? Only through this circular area the rays will come out. Somehow, if I block these rays by keeping a disc, nothing will come out. If I block it, nothing will come out. Anjali is saying B for biotonic. Okay, let's see whether it is B or not. Now, if this is theta c, just observe this triangle, guys. Okay, just observe this triangle. So this is the height, this is the radius, the height is 4 meters, and look at that. Oops. This angle is the critical angle. Can I find that out? Yes. Sine theta c is 1 by mu, so it is 1 by 5 by 3, so it will be 3 by 5. Whose sine is 3 by 5? Whose sine is 3 by 5? Sine of 37. Sine 37 is 3 by 5. You should know this value by heart. If you don't know it, gone. If this is theta c, this is also theta c. Very simple now. If this is theta c and this is also going to be 37, we know what to do next. Tan 37 is opposite divided by adjacent. So tan 37 we all know is 3 by 4. So guys, I'm going to get R is equal to 3 meters. So you should know the values of sine, cos, tan, etc. of 37, 53. In case you have forgotten, I'll teach you a simple trick. What is the trick? Observe this. Draw a right angle triangle. You all know 3, 4, 5 is a Pythagoras triangle, Pythagorean triplet. Do you see 5, 3 over here? Do you see 5, 3 over here? So just mark 5, 3, 53. So naturally this angle will be 37. Now you know all the ratios. Done. Simple. Okay, so that's how you can always draw this triangle and save some time or not get confused. So draw 3, 4, 5, 5, 3, 53. Obviously other angle will be 37. So next, everything else you know. Okay, cool. Thank you guys. Let's get going. Yes, the correct answer was 3 meters B. Excellent. Next question. Beautiful question. There is a convex spherical refracting surface with radius r. It separates a medium having refractive index this much. An object is moved towards the surface from far away to the surface along the central axis. The image will change from virtual to real or real to virtual. Let me explain this question. This is slightly tricky. Very few people will get it. Okay, so there is a convex spherical surface. So this is my spherical surface. Okay, and here the refractive index is 5 by 2 and here it is 1. Okay, now visualize this. If the object is at infinity, what will happen? The object is at infinity, the rays will bend and probably the image will be formed over here. So this is obviously a real image. Correct, guys? This is nothing but a real image. The rays will bend towards the normal because it is going from rare to dense, so it will bend towards. Now, as you bring the object closer, probably, there comes a point when the object is so close that the rays probably go like that. They go like that. So hence, probably the image forms over here and this image will be virtual. What will be this image? This will be virtual because the rays, when the object is here, okay, it goes like that. If you extend it backwards, you get the image. So clearly there is a point where the real image converts to virtual image. How will that point be located? Simple. There will be a point somewhere, I don't know where, somewhere, where when you place the object, instead of the rays converging or diverging, the rays will go parallel. Why? Look at this. When the object is in this blue region, the rays are converging. At red, it becomes less converging and becomes parallel. Beyond this red, in this green region, it has gone into diverging mode. So there is a point where the rays go from converging to parallel to diverging. That's the point where it goes from real to virtual. It goes from real to virtual. So now think, where is the image? The image is at infinity. Which formula do we need? The formula that we need is mu2 by v. So mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. What is mu2? It's 5 by 2. What is image? Well, that's infinity. Minus, what is mu1? That's 1. What is u? Oh, that's what I need to find. Mu2 minus mu1, 5 by 2 minus 1. What is r? I don't know, but I'll just put it as r. Great. 1 by infinity, 0. So this whole term becomes just 0. And therefore, solving this, I'll get 1 by u with a negative sign. 5 by 2 minus 1, 5 minus 2, 3, 3 by 2. So 3 by 2r. That will give me u is equal to minus 2r by 3. So 2r by 3. Yes, I have 2r by 3. So it changes from real to virtual when the object is at a distance of 2r by 3 from the surface. That's the answer. Why infinity, Rishabh? Because, see bacha, the rays were earlier converging when you are really far. That means real image. And when you are very close, they were diverging. That means virtual. So there is a point where that real shifts to virtual. So there must be a point, correct? There must be a point where real shifts to virtual. At that point, instead of converging or diverging, the rays will become parallel. Now, whenever rays are parallel, that means either the object or image is at infinity. No image is formed. That's a better way of putting it. So that's why I've said image distance is infinity. Is that clear? Okay. Kumkum bacha, don't worry. Even if your physics is weak, just attending my lectures and the crash courses, trust me, is going to improve your marks. Even if you are getting, I don't know, even 20 marks in physics out of 180, or even 50 marks in physics, even if you improve it till 70, 90, 100, isn't it good? But I feel your marks will not improve from 20 to 50. I feel for sure, if you attend all my classes and the crash course, I will tell you guys, your marks will improve more than 120. You can reach easily 150. Trust me on this. It's very much possible. Do not give up. Even if you are getting 10 marks or 30 marks, trust me on this. You can go till 150. Even in these last few days, just some systematic strategic study. Attend my strategy session on 150 marks in NEET for physics. I've given you all those things. Okay, chalo. Come on, let's go ahead. A spherical surface. Pay attention carefully. Don't lose focus. You have to become doctors. Keep this in your mind. Keep this in your mind that this is your last few weeks. That's it. The struggle for getting into that college you dreamt of, getting into the course you dreamt of is going to be over. Okay, so push yourself, guys. Think about what you have to do. What is your aim in life? Do not give up just because of one subject, and look at the bigger picture out there. Let's do this. A spherical surface of so much of radius, everything is given, radius of curvature, everything is given. Now I'll explain this question, guys. I'll spare you the time. Pura padne ki zarurat nahi hai. Everything is given. See, radius is given. The object is also given. Where is the object? The object is P. So this is the object. Okay. This is the image. Okay. And PO, P to O is O to Q. Okay. So let's assume this much is X. So this much is also X. Cool. How will the rays come? The rays will come from the object, probably like this, and they will probably meet at the image. So these are the incident, these are the refracted. Okay. Bahar ka medium is refractive index 1, andar ka medium refractive index 1.5. Use your formula, you will get it, guys. What is the formula? Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Try this out. Okay. What is mu2? Where the refracted rays there. This is refracted. So this will be 1.5 by V. What is V? Image distance. Image distance is not negative. A lot of people make the mistake. This is the positive side. This is the negative side. This direction is positive. Incident rays are coming this way. Be careful. This is positive. That is negative. A lot of people make the mistake. So image distance is plus x minus mu1. That's refractive index of medium 1. U, that's negative x. This is minus x. Is mu2. So that's 1.5 minus 1 divided by r. What is r? Probably that's not given. I just keep it as r. It will be plus r because it is over here, radius of curvature. Okay, so what will I get over here? I'll get 1 by x common, and this will be 1.5 plus 1 is equal to 0.5 divided by r. So this will be 1 by x. 1.5 plus 1, 2.5. 2.5 as it is equal to 0.5 by r. Now you know guys what to do. 0.5 and 2.5, 5 times. So cross multiply. X will go here, r will go here, so 5r. Hence the answer is B. That's it. Done, done, done. Very good. R is 1.5. No, refractive index is 1.5. Radius of curvature is not 1.5. Be careful. Okay, thank you Sonakshi. Yeah, that's how it is. Dr. Aishwarya, I will teach all the important chapters, high weighted, high scoring chapters. For other chapters, I feel that you should join the crash course so that you get an in-depth all chapter revision right from 11th to 12th. Okay, cool. Ramesh, no, I have come on this channel many times, bacha. है ना, तो बहुत बार आ चुका हूँ. You can check my lectures. See, very simple to search any of my class. Shreyas Sir, Biotonic. Shreyas Sir, any topic name. Shreyas Sir, communication system, you'll get a lecture. Shreyas Sir, logic gates, you'll get a lecture. Shreyas Sir, semiconductor, you'll get a lecture. Shreyas Sir, electromagnetic induction, you'll get a lecture. So you can easily search any of my classes. So that's the jadui mantra, jadui word that you should type in the YouTube search bar. That's it. Okay, you will get all my lectures. Okay, cool. Now, going to lenses. Going to lenses. Before that, छोटा सा पानी का ब्रेक. ठीक है, पानी का ब्रेक थोड़ा. क्या बोलते हो गाइज? रेडी हो जगने के लिए 11 o'clock के बाद? नींद तो नहीं आ रही ना? यस, ओके, बहुत बढ़िया. I know. You have seen my lectures on JEE channel, but here I come very rarely. You know. Yo warriors, get ready. आज मैं सुबह, I woke up at 5:50. I went for a run. I ran for 3 kilometers. That's how my day started. And I thought, when I told Vani ma'am, okay, I'm coming at 9 o'clock. I thought initially maybe I'll be tired, but trust me, I'm not even tired a little bit. Not at all. I don't even feel like sitting down. The only thing is my throat dries up in between. So that's when I have to drink water. But energy, josh wise, thoda bhi matlab entho down nahi hai mera. I'm fully ready. Yeah, I don't know about you. I think you guys are also ready. I can see all the hearts and all that. Very good. Because mera ek hi aim hai guys. You have to crack the NEET exam. And I cannot teach you all the subjects. Vani ma'am is already teaching you so well. Bio, zoo, everything. So only contribution I can do is in physics, and मेरे को लगता है that is something which you need right now. And physics के marks अगर आपके improve हो गए, if you get very good marks, you will automatically improve your overall score of NEET. That will help you a lot. Okay, so let's try this. Let's not give up so easily. चलो lenses के बारे में बात करते हैं. Okay, so lenses के लिए first of all I had told you formulas are exactly similar. बस एक ही फर्क है. There is only one small difference. Instead of plus, you will have minus. That's it. Nothing else. Nothing else. Okay. So 1 by v minus 1 by u. Linear magnification. V by u. Mirrors में minus v by u था. Okay. Next up, longitudinal magnification. V square by u square है. वहां पर minus v square by u square था. Keep in mind, this is width of the image. Width of the image upon width of the object, which is also image velocity upon the object velocity. तो अगर इमेज मूव हो रहा है और ऑब्जेक्ट मूव हो रहा है तो इमेज वेलोसिटी निकालने के लिए provided object velocity is given, use this ratio. It is always v square by u square. Great. Next, अगर lenses को साथ में रखते हो, if you keep the lenses together, thin lenses in contact, then what will happen is the powers will get added. Remember the formula for power is 1 by f. अच्छा, एक common catch. I have seen many people substitute focal length in centimeter, 1 by 10 centimeter. अच्छा, it is 0.1. Wrong. This has to be in meters only. You cannot substitute centimeters. Keep this in mind. Okay. So the powers get added when lenses are in contact. P1 plus P2 is total power. Matlab 1 by f is equal to 1 by f1 plus 1 by f2. One small formula, which probably I can give it over here or maybe over here also. Doesn't matter. Lens maker formula, probably it was not there on the slide. तो मैं यही कहीं तो लिख लेता हूं. अगर आपके पास कोई लेंस, एनी लेंस, some radius of curvature r1 and some other radius of curvature r2, then the lens maker, so to make that lens maker formula is 1 by f is equal to mu of that lens relative to the outside medium minus 1 by r1 minus 1 by r2. So this is your lens maker formula. r1 and r2 are the radii of curvature with the sign convention. Keep this in mind. Mu relative मतलब क्यों बोला मैं? बाहर का medium if it changes, then always make sure it is relative refractive index, not absolute refractive index. All right, let's get going to the next one. How do you know when to use these formulas? It will be like depends. मतलब किस तरह का magnification पूछा है या how is the object moving? Is the object moving given? Yeah, then you need to use image velocity by object velocity. तुम problems देख लो, you will obviously start seeing it. Every time it's not necessary, formulas are directly applicable. कुछ तो थोड़ा सा दिमाग लगाना पड़ सकता है, ठीक है? So I mean it should be probably done in this way. Whenever you solve or whenever you are looking at a new chapter and you are not so confident with the formula application part, एक ट्रिक जो मैं हमेशा बोलता हूं is solve the easiest problem, जहां पर सिर्फ सब्स्टिट्यूशन वाले क्वेश्चंस हैं डायरेक्ट. उस टाइप के क्वेश्चंस बहुत सारे करो, फिर तुम्हें समझ में आने लगता है कि अच्छा कब क्या यूज करना है, what are the signs, what are the traps laid usually in these formulas. वो एक बार थोड़ा सा समझ में आ गया, उसके बाद you can go to the average problems and then you can go to the difficult problems. So that's what I usually tell. Okay, चलो, let's see whether you can get this. अब इसमें कोई formula नहीं है. Now you will see that this is not based on any formula. This is based on little bit of logic. See, there is a biconvex lens. Okay, there is a biconvex lens. So this is my principal axis and focal length f forms a circular image on the focal plane. Focal plane मतलब wherever you have the focus on that plane. So maybe if this is the plane, which is the focal plane, तो यहाँ पर you are getting the image. You are getting the image. Okay, so this is basically your focal length. Now, how will this image be formed? Simple. See, the rays will be at infinity, coming from infinity. Only then the image can form at focal point. So, think about this. If I draw a ray to the center of curvature, things will become simple. I'll tell you how. Look at this. This ray, okay, ये ऐसे बना दिया, ये लेंस है आपका, and this is the radius, this is the focal length, this is the radius of that image. Now the reason why I drew the ray which passes through this pole is because that ray will always be undeflected. मेरे को पता है, it always goes at the same angle here and there. That's the property of a ray diagram for lenses. याद है कि नहीं? So hence guys, look at this. If this angle is same, okay, you can just see that r by f is a constant. Do you see r by f is a constant? Because tan theta will be constant, the angle will be constant because that will be equal to tan theta. So r is proportional to f. So r square is proportional to f square. Now question में देख लो क्या है, pi है. तो pi is a constant, कोई बात नहीं. So pi r square is also proportional to f square. That's how you solve the problem. Got it? That's how it is. Very good. Why not C? Okay, if the lower half is covered by the black sheet, then the area of the image will become, ये actually pi होना चाहिए, pi r square by 2. काफी लोग ये सोचते हैं. Very good thinking. See, understand, when you cover the lower part, ऐसा नहीं कि आधा image गायब हो जाएगा. No. See, the intensity of the light will reduce. See guys, understand, let me draw another diagram. Whenever you have lens and whenever you have an object over here and you have an image, आपको ऐसा लग रहा होगा कि जो रेज ऊपर से जा रहे हैं वो एक पार्ट ऑफ द इमेज बनाते हैं, दूसरा पार्ट नहीं बनाते हैं. दैट्स रॉन्ग. The rays which go from below also make that image. Okay, the rays which go from below also are making the image. Now when you remove this part or cover it with black paper, the number of rays coming will decrease. If the number of rays coming decreases, image will not become half. Image will become half in intensity. Brightness कम हो जाता है. The size of the image will not be affected. Is that clear? Okay, great. Chalo. So that's why it is not C. Okay, it is B. Correct. Chalo, let's see how many of you get this. Risha, I'll come live on Instagram some other day, bacha. Now I have not even seen Instagram properly. I've just been resharing the post because I'm really working, day and night for many things right now. So बिल्कुल भी time नहीं है Instagram के लिए actually. But I'll come someday for sure. Okay, which of the following is true for the rays coming from infinity? कितने images बनेंगे? How many images will be formed? Continuous image, one image, two images, or none of the above? Okay, some of you are saying C, some of you are saying A. Guys, the answer is two images are formed because think this way, जो ऊपर का, yeah, very good, ऊपर का lens है, that will form a focal point here, and नीचे का जो lens है, it will form a focal point here. So there are two images formed. Any other ray coming here will also meet here. Any ray which is coming here will also meet here. So there are two images which are formed. These are like two different lenses. Keep this in mind. Okay, cool. Going to the next question. A convex lens, AIPMT 2003 question. Convex lens is dipped in a liquid whose refractive index is equal to the refractive index of the lens. तो focal length क्या हो जाएगा? बहुत ही बढ़िया question. You should get it within 20 seconds. Within 20 seconds. C for cool, C for capto. Come on. Zero. Small but non-zero. कुछ लोग बोल रहे infinity. Come on. Be careful. काफी लोग, many of you are going to lose marks. Correct, guys. Some of you are correct. The answer is actually infinity. The reason for that, see, you can go by formula also. Mu minus 1. यहाँ पर 1 by R1 minus 1 by R2 है. फर्क नहीं पड़ता. This is mu relative. This relative will become 1. Outside and the medium of the glass is the same. So 1 minus 1, 0. So 1 by f is 0. So f will go to infinity. Flip it. 1 by 0 is infinity. You can also look at it other way. If there is medium inside, if the glass and the medium outside have same mu, the rays will not even bend. They will not even bend. So the focal length will be at infinity. They will not converge or not even diverge. Okay, it's the same medium. Very good. Next question. This time the medium is different. AIPMT 2006. Convex lens and concave lens each having, oh sorry, no, it's not about medium, my bad. Have same focal length of 25. They are put in contact to form a new lens. The power in diopters of the combination. Come on. You guys should get this. You guys should get this. What is the power? Ritvika saying D. PUBG Car saying A. Come on. Rakesh saying A. Vandana saying A. All right. You should be careful about this question. ध्यान से देखो, it is convex and concave lens. So the answer will be 0. So it's like saying, you have a concave as well as a convex lens. दोनों का powers will be same but opposite in sign because focal lengths are same. So think about it. If it is 1 by 25 for one, for the other one it will be minus 25. So the answer for the effective focal length, socho, this is nothing but, oh by the way, this is nothing but the effective power. You directly kar sakte hain. So you can see that effective power will be 0. It is 0. One is convex, one is concave. Magnitude diya hai 25 centimeter. Be careful to substitute the sign. Read the question carefully. How much ever it converges, it will become divergent. So hence guys, the answer is 0. Be careful. Next question. No, Srimati, it is not 100 by 25. That is wrong. Be careful. It's convex and concave lens. So convergent and divergent will cancel. So, you know, it will, yeah, power will be 0. Alia, come on, bacha, half an hour more. Come on, push yourself. An equiconvex lens, AIPMT 2003. Once it is cut like this, once it is cut like that, what are the focal lengths each time? Come on, figure this out. The focal length is going to be how much? First time, in case 1, okay, in case 1 you are cutting it along XOX. Okay, this is case 1. If you cut it like that, you are going to get a lens like this. Now guys, this lens is the same as the original lens. This is nothing but this, because see, if the rays were coming and meeting at some point, the rays will still come and meet at the same point. Focal length will not change. So F will be, in the first case, F only. It will not change. But in the second situation, you need to be a little bit careful. When you cut it like that, you will get one half over here and the other half over here. If you add both these lenses, you get this lens. If each one of them has focal length f2, okay, adding the reciprocals, I should get this focal length. So therefore 2 by f2 is 1 by f. Hence f2 will be, look at that, f2 will be twice of the focal length. So guys, the focal length will become twice because the power will become half. So hence it will be 2f. So it will be f and 2f. Keep this in mind. That's why the correct answer is option A. So when you cut it vertically, you will get two plano-convex lenses. Each plano-convex lens will have half power, and power is ulta of focal length. So it's reciprocal. So if power becomes half, focal length will become twice. That's how it is. Very good, very good. Lot of people would have thought that, the focal length will become half. Nah, it's not going to become half. That's wrong. Okay, many of you make that mistake. Next question coming up on your screen now. Okay, a convex lens of itna refractive index has itna power in air. If it is now placed in a liquid of this much refractive index, then the new power of the lens is how much? Come on. Let's do this. So first of all, try to understand, we have to find the power, okay, in the new medium. So in the air, focal length in air, okay, is not given, but I know the formula. It is mu minus 1. So what is mu? Mu is 3 by 2 minus 1, and you will have 1 by R1 minus 1 by, okay, R2. Okay, cool. Now this 1 by F is the power. And what is the power? It is 2.5. So this will become 2.5 is equal to 3 by 2 minus 1. That's 1 by 2. Okay, into 1 by R1 minus 1 by R2. 2.5, well, that's 5 by 2. So 5 by 2, or take 2 over here, it will just become 5. So 5 is equal to 1 by R1 minus 1 by R2. Okay, keep this aside. Now the question says, when you place this lens in another medium, what's the new power? The new power will be 1 by new focal length, and that new focal length will be relative mu. So what is that relative mu? Relative mu will be refractive index 3 by 2 by refractive index of the medium, which is 2. This is relative mu. Okay, refractive index of glass with respect to the outside medium, minus 1 into 1 by R1 minus 1 by R2. Now this will become nothing but 3 by 4 minus 1. This value I know is 5, so just put it over here. Okay, 3 by 4 minus 1 is minus 1 by 4 into 5. That's your new power. So this is 5 by 4, which is 1.25 diopters with a negative sign. So that's option A. Yep. Very good, Gayatri, Ritvika, Subarno, very good, Alia, very good, Sanvi, very good, very good. Excelente, excelente. Good, very good. Let's get going to the next one. Okay, that's the answer. Correcto. Next question. Many people get confused in these kind of questions. I'll give a simple trick to do this. There is a plano-convex lens. The plane surface is silvered. The question is find the new focal length after silvering. I'll tell you what. You can do this small trick. Because it's plano-convex and the plane surface is silvered, whatever, it's a mirror, right? It's a mirror. So whatever is there in the front will be reflected behind. Whatever is there in the front will be reflected behind. So treat this like a normal convex lens and forget that there is a plane surface. Just forget that this plane surface is there. So just find the focal length using your lens maker formula. What is mu? Mu is 1.5 minus 1 into 1 by r. What is the radius of curvature? Well, that's 10. Okay, the first surface will have plus 10. The second surface will have minus 10. Okay, why minus 10? Because think about it, this will be R2. So, you know, it will have negative radius of curvature. R1 will have positive radius of curvature. So that's why. 1.5 minus 1, that's 0.5. Okay. Minus minus plus, so it will become 2 by 10. 0.5 into 2, 1. So that's 1 by 10. So obviously focal length is 10 centimeters. Where is this? It's 10 centimeters. That's the answer. As simple as that. Yeah. Isn't it easy? So whenever you have a mirror, reflect it, you will get the answer. As simple as that. Okay. Let's get going to the next one coming up on your screen. Okay. Coming to prisms. Yes, we are slowly coming to the end of the chapter. Prism and optical defects. Two more small things left. Quickly, let's go through the formulas. Don't let the Josh die down. Push everybody. Come on. Let's do this. Whenever you have a prism, this angle at which it falls inside the prism is incident angle. It refracts at angles R1 and R2 inside the prism, eventually deviates and emerges. This is called as the emergent angle or I2. The total angle by which it shifts is delta, which is angle of deviation. The angle of the prism is at the top, the angle between these two surfaces, which is also called as the angle of prism. Okay. Now, oops, this was not supposed to come first, but whatever. Oh my God. Okay. Okay. So, first of all, delta is I1 plus I2. Okay, I1 is not there. I'll just mark it over here. This was supposed to be I1 plus I2 minus A. This is actually I2. This is nothing but I1. Keep this in mind. So delta, this angle of deviation is given by I1 plus I2 minus A. A is nothing but this angle of prism. Keep this in mind. Angle of prism. That's the first formula which you should know. Second formula. If you plot deviation for different angles, the graph looks like this. At one particular point, it is minimum. And that happens when both incident and emergent angles are equal, R1 and R2 are equal, and the condition for that is sine A plus delta by 2 upon sine A by 2. Cool? Great. Very good. So that's the formula which you can only use for minimum deviation, not otherwise, not for any random deviation. This formula is applicable for all the deviation angles. This is a generic formula. Keep this in mind. Alright, there is one more formula which you can remember. R1 plus R2 is equal to A. So this R1 plus this R2 is equal to this A. Keep this in mind. Okay, this is another formula which you should know. Okay, it's not there over here, but you can write it in the notes. Okay, next up. Dispersion without deviation and deviation without dispersion. So before going there, let's do this one by one. See, whenever you have a thin prism, thin prism means what? See guys, this angle is small. That is called as a thin prism. Then that angle by which the rays deviate, okay, that will be given by A into mu minus 1. This is only for thin prism. Thin means angle is small, the angle of the prism is small. Only then you can use this. Now, there are two formulas which you should know. See, whenever you have a prism, guys, there are two extreme rays. One is the red color, okay, the red color deviates the least, and the violet color deviates the most. Now, if you measure this angle between the extreme two rays, that angle is called as delta omega. So this delta omega over here is nothing but this angle, the angle between the extreme two rays. When white light enters inside, it splits, it disperses. So it is delta of violet minus delta of red. So delta violet minus delta red will give you this delta omega. And this omega average stands for the average deviation. This is average deviation. So this is the delta of yellow color. How much does yellow color? Yellow will be somewhere in between. How much does yellow color deviate by? So yellow color, how much did it deviate by? So this ratio is called as dispersive power. Okay, this ratio is called as dispersive power. Keep this in mind. Great. Now, two cases. Don't remember the formulas, although I have put it down over here. Just remember one thing. Whenever I say dispersion without deviation, or whenever somebody says deviation without dispersion, see what is not happening. What is my rule? The rule is see what is not happening without deviation. That means deviation is not happening. That means that yellow color, that average color which deviates in the first prism counter deviates in the second prism. So both the prisms will have same angle of deviation, because in the first prism, whatever angle it deviates by, the same angle it deviates by in the second prism. So the final ray, average color's final ray and the initial ray are parallel to each other. So there is no deviation on an average. So that's what it means. So there is no deviation of the average color or average wavelength. But when I say deviation without a dispersion, that means the amount by which the light spreads in the first prism, it converges by the same amount in the other prism. Deviation without disperse. Disperse means spread. So whatever it spreads in the first, it spreads or converges by the same amount in the second. So the delta omega will be same. So the spread will be same, so that they counter each other and cancel each other. Keep this in mind, okay? So that's what you need to do, nothing else. Okay, let's start solving some questions coming up on your screen now. Don't lose hope. A prism having some angle over here. Let me see if you can solve this within a minute. Come on, my warriors. 1 minute to solve the question. Got it? Okay. So a prism having apex angle 4 degrees, refractive index 1.5 is located in front of a plane mirror as shown. Through what total angle is the ray deviated after reflecting from the mirror? Come on, figure this out. Think about it. Yes, Shreyas, the beast mode is on. The beast mode will not go off. Very good, Saili. Very good. Come on, Sarah saying D. Pragati saying D. Akshay saying A. Subarna saying D. Keshav saying D. Gayatri saying C. Interesting. Come on, you need two formulas over here. One is the prism, one is the mirror. Very good, very good, very good. Let's see. Come on, my warriors. Figure this out. Happy boy, I'm going to take modern physics classes, so nuclear physics will be covered in that. Don't worry, I'm going to take modern physics as well. Okay? So be happy, boy. Okay. Chalo, let's see. I love this bell. Okay. And what's going to happen is that the ray will deviate. Okay, so it's going to deviate and probably, I don't know, maybe like this, and if I draw normal out here, probably it will deviate like this. Okay, cool. So how much did it deviate by? How much did it deviate by? That delta is A into mu minus 1. A is 4, mu is 1.5 minus 1. 1.5 minus 1, 0.5. 0.5 into 4, 2. So it deviated by 2 degrees. Now if it deviated by 2 degrees, think if I draw normal over here, okay, just let me draw this, deviated by, you know how many degrees? Delta was 2 degrees. If you draw a normal over here, you will see this is the angle of incidence. That angle of incidence is also going to be 2 degrees. So finally when it reflects, so that deviation, think about it, that deviation is 180 minus 2i. So it is 180 minus 2 into 2, which is 176 degrees, which is option A, guys. After reflection from the mirror. That's the question. Thank you, Ritvika. Yes, crystal clear, says Soumya. Very good. Excellent. Let's get going to the next one. Okay, so the correct answer is 176. Beautiful. Next question coming up on your screen now. The angle of incidence for a ray of light at the refracting surface of prism is 45 degrees. Okay, the angle of prism is 60. If the ray suffers minimum deviation through the prism, what is the deviation and the refractive index? Interesting. Oops, I don't want this. Okay, one second. Okay, so let's try this question. So first of all, let's see what and all is given. In that prism, the angle of prism is 60 and it is clearly mentioned there is minimum deviation. So at minimum deviation, keep this in mind, I1 is equal to I2, R1 is equal to R2. Okay, so the angle of incidence is 45 degrees. So this is 45 degrees. So I1 is equal to I2 is equal to 45 degrees. Cool. What is the deviation? Acha, I know the formula. Delta, remember, is I1 plus I2 minus A. So I1 is 45, I2 is also 45, A is 60. So 90 minus 60, 30 degrees. So delta is 30 degrees. So either it could be option A or it could be option C. Okay, so what to do next? Actually, you can sit and eliminate. You can directly eliminate C because refractive index cannot be less than 1 for a glass. Isn't it true? So in the exam, don't even have to solve. Eliminate C and directly go to A. Makes sense? But just to tell you how to solve it, what you should do, use this formula. Mu is sine of A plus delta by 2 upon sine of A by 2. Just use that, you will get the answer. So sine of A, what is A? A is 60 and delta, that's 30. So 60 plus 30 by 2 by sine of 60 by 2. So you're going to get 60 plus 30, 90, 90 by 2, 45, sine of 45, 1 by root 2 and sine 60 by 2, sine 30. Sine 30 is half, so 1 by 2. So this will become root 2. Hence the answer is option A. Yes. Very good. So that's how you can solve it. Okay. Cool. Let's get going. So you have to eliminate options in the actual exam if it needs to be done. Next question coming up on your screen. Guys, there is no comma here. That's by mistake. Okay. Let's see if you can do this. This is minimum angle of deviation. And the question is material of the prism, refractive index of the material of the prism is cot A by 2. Angle of minimum deviation is. Interesting. The moment angle of prism is given, refractive index is given, deviation is asked, I know which formula to use. The formula I need to use is mu sine of A plus delta by 2, because this is again minimum deviation. This is always for minimum deviation. Sine of A by 2. What is mu? Mu is given to be cot A by 2. So let's do this. So cot A by 2 is equal to sine of A plus delta minimum by 2 divided by sine of A by 2. Cot is cos by sine. So cos A by 2 divided by sine A by 2 is equal to sine of A plus delta m by 2 divided by sine of A by 2. Sine of A by 2, sine of A by 2 cancels, correct? These two cancel, so I get this. So cos A by 2 is equal to sine of A plus delta m by 2. Let me do one thing. Since there is 90 plus minus 180 plus minus, convert cos into sine. How? Cos is sine of 90 minus theta. So 90 minus A by 2 is equal to sine of A plus delta m by 2. Now the reason why I converted this into sine is when I have two equal sines, their angles will also be equal. Correct? Their angles will also be equal. So 90 minus A by, come on. Actually, yeah. So take LCM, that will be better. Yeah, take LCM, guys. Everybody understanding this? Yeah. So this will be nothing but 180 minus A by 2 will be equal to A plus delta minimum by 2. 2 goes. Shift these terms. 180 is equal to 2A plus delta m. So delta m will be 180 minus 2A, which is option B. Option B. Very good, Ritvika. Very good. Thank you, Soumya. Very good, Ram. Very good, Gayatri. B for bingo. B for bad angle bingo. Very good. I hope you have not turned bad. Okay, let's get going to the next question. And there we go. Kya ho raha hai idhar? The wavelength of light is increased. Come on, theoretical question, you should get it. Then what will happen to delta, refractive and frequency if the wavelength of the light is increased? Think, guys. F into lambda is speed of light. If lambda increases, frequency will decrease. Straightforward. Okay, cool. When lambda increases, basically you are going from blue color to the red color. And for blue color, refractive index is blue deviates the most. So mu of blue or violet is more than mu of red. In fact, deviation of violet is also more than deviation of red. So guys, see what will happen when you go from blue to red. The wavelength increases, refractive index decreases, deviation also decreases. So everything will decrease, hence option A. Drashti, more 15-20 minutes, not more than that. Okay, it's a beast mode lecture, so I have turned on my beast mode. So I started my class at 9 o'clock, so maybe till 11:15 or so. Not more than that. Okay, next question, AIPMT 2004. Yeah, Drashti. Okay, come on. Next question, the refractive index of the material of a prism is √2. This looks scary, but trust me, it is not. And its refracting angle is 30. Refracting angle is 30. And the other surface of the prism is made of a mirror inwards. A beam of light which enters from the one face will retrace the same path from the mirrored surface if the angle of incidence is. Always start with diagram. Always start with diagram. Let's see. How does it look like? First draw the prism, normal prism. Okay. And the ray of light is falling inside. It refracts and it retraces back. Why is it retracing? Well, let me tell you what is happening. In that prism, one of the surface is a mirror. One of the surface is a mirror. So whatever ray goes inside retraces back, and a ray can only retrace back after reflection from a mirror only if it is falling at 90 degrees, at perpendicular, normal. So the ray must be incident normally. Only then it can retrace back the same path. Everybody agrees? So whatever path it goes, rebounds perpendicular and comes out. Okay. Now, let me tell you, it's a matter of just marking the angles. Trust me on this. This is, let's say, angle of the prism. Okay, the angle of the prism, refracting angle is 30 degrees. Okay, so basically this is 30. If this is 30 and this is 90, how much is this? This is 60 degrees. And if this is 60, how much is this? This is 30 degrees. Correct? The question is, what is the angle of incidence? So the question is, what is this angle I? Guys, I just figured out what is the angle of refraction. I need to find out I. Mu is given. Now it's very simple. Just use Snell's law. Nothing else. So sine of I by sine of 30 is equal to mu. So basically sine of I is mu. Mu is √2. into sine 30, which is 1 by 2, which is 1 by root 2. Therefore, if sine of something is 1 by root 2, I is 45 degree, which is option A. Done. Got it? Got it? Clear? So it was just all about drawing the diagram, nothing else. Glad. So let's go to the last part of today's class, and that is optical defects. I'm pretty sure you have learned about myopia or short-sightedness and long-sightedness in bio, and you know very well about it. So I will not, the disease. I'm pretty sure you know more about this than me because you are studying bio. Okay, but I'm not going to the bio part. So I'm just going to the physics part. Just 2 questions and that's it. A short-sighted person, a myopic person can see near objects, distant objects are not seen clearly. So when he tries to focus very far away objects, the rays converge much before inside the eyeball, before the retina. In order to correct it, you use concave lenses. So when you try to relax your eye watching a distant object, okay, the rays converge behind and you have to use a suitable lens of a correct focal length. How? See, whenever you use or solve problems for myopia, remember you should be able to see objects at infinity. Usual normal person's far point is infinity, near point is least distance of distinct vision, which is 25 centimeter. So if you observe a mountain which is object distance is infinity, then if that image forms at your far point, then you will be able to see it. So you wear a concave lens such that the mountain's image is formed closer, and now you know that you can see it because you have only a certain limitation till which you can see the object. So you bring the object closer. That's what you do because your eyes cannot relax beyond a point. Okay, so use your lens formula. Object at infinity, image should be formed at x. X is your near point, far point. Great. Next up, hypermetropia. So that's long-sightedness or far-sightedness. In that case, usually what happens, you can bring an object close to your eye. Your eyes muscles will, adapt themselves and they will put a strain on your eye such that you can focus clearly to a near object. But some people are unable to do that, and it can happen because of age as well. And then the image is formed behind the retina. So in order to remove this defect, because you are not able to focus properly, you use a convex lens. So what you do, understand the normal distance of distinct vision is 25, but maybe your least distance might be 40 centimeters. So when you bring an object at 25, you push that object far away so that you can see clearly only after 40 centimeters. Example. So usually least distance of distinct vision is 25. So an abnormal person, what he will do? He'll make sure that he wears a convex lens so that the image is pushed behind which is a safe distance for him to view it. So that's what is done. Okay, using the lens formula, the object is at Y and the image should be formed at I think this shows ulta, guys. This is not supposed to be like that. The object is supposed to be at D. I'll just correct it. The object at D, the image should be formed at Y. Okay, I'll just correct it later on. Okay, in the PDF. Okay, cool. Let's solve the last 2 questions. Okay, let's do this. Optical instruments. You can watch another lecture of mine from Zero to Hero series. I have conducted. I'll just show you where it is. See, even before going over here, if you go to our channel, okay, or if you just search over here, okay, so Zero to Hero optical. Yeah, there we go. Do you see me? Yeah, that's me. Okay, on other channel, but it's okay. Zero to Hero optical instruments. I have conducted a class on this. You can watch this class. Okay, although it's for JEE, but you can still watch it. All the instruments have been covered in detail. Just watch that. Okay, I hope that is fine. Cool. Chalo. Last question. Second last question coming up on your screen now. A man can see up to 100 centimeters. So what is the power of the lens required for him to see the far objects? Come on, my warriors, figure this out. Think. He will use which kind of lens? And what is he suffering from? What is he suffering from? He is suffering from, he can only see till a particular point. He is suffering from myopia. So he has to use concave lens. So if an object is at infinity, make sure that the image is formed at 100 centimeters so that his eye can see it. So use the formula 1 by V. V is minus 100 minus 1 by U. U is infinity is equal to 1 by F, and that means your F will become minus 100 centimeters. The question is for power. Power is 1 by F, so it is minus 1 by this 100 centimeters is 1 meter. So that will be 1 diopter. Just check this out. Minus 1 diopter. Is it there? Yes. Option D is there. Yep. Minus 1 meter. Yeah, minus 1 diopter. Yes, very good. That's the answer. Very good. Focal length. But remember, it's a concave lens, so that's why it should be negative power. Don't mark +1. Be careful. Okay. Chalo. Last question. A presbyopic. He has both the defects. His near point is 30. He cannot see anything before 30. He cannot see anything after 40. So only a small range. The question is, what are the lenses that you will use, guys? So solve it part by part. Okay, so the far point is 40 centimeter. So imagine for the far point, this is what you will do. If he focuses at an object which is at infinity, you make sure that the image is formed at 40 centimeter. That's it. So 1 by V minus 1 by U is equal to 1 by F. So basically 1 by F is 1 by minus 40, but this is in centimeter. So the power will be, 1 by minus 0.4. So that will be 4 by 10, 10 by 4 or 5 by 2. So minus 2.5 diopters. That's for the first part. So that's a bifocal lens. You might have seen some people wear that bifocal lens. Reading glasses and distant viewing glasses, both are in the same one. So one is a concave, one is a convex lens. And for the next part, what you do, for the far point, use your convex lens. So for that near point, here is what you will do. If you place the object at 25 centimeter, make sure that the image is formed at 30 centimeters. So then what will happen? You will be able to see it, because you cannot see 25 centimeters, you can see 30 centimeters. So if you place something, make sure it is seen here. So just use this formula 1 by V. V is minus 30 minus 1 by minus 25, okay, is equal to 1 by F. Correcto? I hope this is clear. Yes. So I hope now you know how to solve this. All you need to do is rearrange this. Okay, so what are you going to get? So you're going to get 1 by 25 minus 1 by 30 is equal to 1 by F. So it will become 30 minus 25 divided by 25 into 30, which is 1 by F. Okay, so just do this, guys. I'm pretty sure you'll get it. So this will become 5 divided by 25 into 30. Correct? And this will become 5. Okay, but this is all in centimeters. 530, which is 150. 150 is nothing but 1.5 meters. So this will be power. So 1.5 is 3 by 2. So that power will be 2 by 3 diopters. Yeah, that's the answer. Okay, cool, clear. Shall we go ahead? Very good. So that's how you solve problems on optical defects, guys. Now, if you want more such classes like that, please let me tell you, there is a link for joining the crash course, which has a lot of lectures from all the amazing master teachers, which will cover the entire syllabus as per the new pattern with full syllabus and part syllabus test series. Also, you'll get live classes plus recording and doubt solving from morning till night. So apart from the tests, there will be performance booster sessions, learning modules for all the subjects, biology, 11th, 12th grade, even physics and chemistry, all subjects are covered. And the course price is not 10,000, it is 4,500 rupees when you use the coupon code SHNEET. It's there in the description box below. There is a link. So if you want more test series, if you want more sessions from teachers like me, please go ahead, join it right now. That's something which you can do. Thank you guys so much for being here, and thank you guys for tuning in till late night. I know it got a little bit extended, but that's beast mode, right? All at the end of the day. Did you love it? And if you loved it, please smash the like button, share it, tell your friends, watch it even if you could not attend it live. That would mean a lot for me. Hit the subscribe button if you are not a regular user for this channel. Yeah, please do that. And I'll see you guys very soon. Leave your comments. I always read your comments. Even the last lecture, I have read all your comments. Okay? Chalo guys. Take care. Sleep well. Sleep tight. Good night. Shreyas here. Hasta la vista.